So, good morning, class. Today we will be studying chemicals, enzymes, and other bioreactive molecules. Okay, so let's see one by one. So, we already know that microbes are also used for commercial and industrial production of certain chemicals like organic acid, alcohol, and enzymes. Okay, and that these microorganisms are used for the productions of chemicals like organic acid. So, let's see the organic acid, that is citric acid, and this citric acid is like abstracted or produced from this aspergillus niger or fungus. This is the aspergillus niger. So citric acid is obtained from this fungus. This is, you can see that this fungus will having a certain brush like structure, certain finger like projection has emerging out from the body, and this will have a certain granules in the outer surface of its like a structure. Okay, and so next acid is the acetic acid, and this acetic acid is abstract from a bacterium called Acetobacter aceti. Okay, now this is the Acetobacter aceti. Now this from this Acetobacter aceti, this acetic acid has been abstracted. Okay, and butyric acid is abstract from a bacterium called Clostridium butylicum. Okay, and you can see that this is the Clostridium butylicum or bacteria. So from this bacteria, this butyric acid is abstract, and lactic acid is obtained from a bacterium itself called Lactobacillus. Now this is the lactobacillus. From this lactobacillus bacterium, this lactic acid is obtained. That means this organic acid is obtained from the this microorganism. So next is the alcohol. So alcohol is also produced by the certain action of the yeast, that is a fungus called a Saccharomyces cerevisiae. Okay, this is the Saccharomyces cerevisiae. This Saccharomyces cerevisiae will be responsible for the formations of a food into the ethanol, that is alcohol. Okay, next third one is the enzyme. Now this lipases, that means lipases are those type of enzymes which will help in the to remove these oily strands from the laundry. That means in the laundry, ठुलो लन्ड्रीमा चाहिँ जुन चाहिँ हामीले लुगाहरू धुनु दिएको हुन्छ हैन, त्यो लुगामा के हुन्छ, सर्टेन ओइल्सहरू, सर्टेन डट्सहरू अट्याच्ड भएको हुन्छ. त्यसलाई हटाउनको लागि चाहिँ नाउ दिस लाइपेसेस एन्जाइम इज युटिलाइज्ड, सो दैट दिस लाइपेसेस एन्जाइम विल ब्रेक डाउन द all the oil particles. Okay, so next is the pectinase and proteases. Now this is to clarify the bottle juices. That means in the bottle juices, okay, these two types of these like enzymes will be added in the market, so that it will be very like a clear, pure, right, as compared to the juice which is present in the home. That means the juice that you have brought from the market and the juice that you have made in the home, if you compare between that two juices, then you will find a large comparison between two these juices. It is just because this proteases and pectinase is used in the to clarify the bottle juices of the market. This enzyme is not present in our home, not utilized in the juices that is made in the home. Okay, so streptokinase is another type of enzyme. Now this streptokinase is produced by this streptococcus bacteria, and it is used as a clot buster to remove clot from the blood vessels of patients who have a myocardial infections. In the myocardial infection मा के हुन्छ भने चाहिँ हाम्रो ब्लड भित्र आफै ब्लड क्लट हुन्छ, ब्लड जामिने चान्सेस हुन्छ. यतिखेर चाहिँ ब्लड क्लटिङलाई नहोस् भनेर चाहिँ सो के गर्दो रहेछ भन्दाखेरि चाहिँ certain enzyme is utilized in the patients, that is streptokinase, and this streptokinase is obtained from the streptococcus bacteria. You can see see the coccus means the spherical shape of the bacteria. You can see the chain of the coccus bacteria. From this streptococcus bacteria, now this streptokinase enzyme is obtained and will be injected to the patient having these infections, myocardial infection. Okay, so next one is the cyclosporin A. This is produced by the Trichoderma polysporum fungus. From this fungus, now this cyclosporin A is obtained and it is used in the immunosuppressive agent in organ transplant patients. So when, for example, if a person is एउटा पर्सनको मा चाहिँ के भयो किडनी फेल भयो अरे ओके अनि यो पर्सनको किडनी चाहिँ कसले दिनु पर्यो सेकेन्ड पर्सनले चाहिँ किडनी डोनेट गर्नु पर्यो उ भयो रिसिपिएन्ट नाउ अनदर वान इज द डोनर नाउ डोनर विल डोनेट द किडनी after finding the match the similar match between the two person that means that is the HLA match, the blood group matching, सबै कुरा match भइसकेपछि चाहिँ when the kidney will be donated to the recipient, to the patient 1, then that patient 1 को body मा recipient को body मा चाहिँ certain antibodies हरु produced हुन्छ, immune system हुन्छ. Now this immune system antibodies produced भएर चाहिँ बाहिरबाट आएको organ लाई चाहिँ they will be considered as a foreign and that is the antigen that has to be removed from the body. It is not good for health भनेर उनीहरुले त्यस्तो खालके एउटा रिएक्सन देखाउँछ. अब त्यो रिएक्सन कन्टिन्युस भयो भने चाहिँ फेरि किडनी फेलियर हुने चान्सेस हुन्छ बडीले एक्सेप्ट गर्दैन. ओके टु रिमुभ दैट सप्रेस जुन चाहिँ एउटा के छ भन्दाखेरि चाहिँ रिपल्सेन्ट छ जुन चाहिँ एउटा रिपेल गर्ने एबिलिटी छ त्यसलाई सप्रेस गर्छ. दैट मिन्स जब इम्युनोसप्रेसिभ एजेन्ट दिस साइक्लोस्पोरिन ए इन्जेक्ट गर्छ पेशेन्टको बडीमा त्यतिखेर चाहिँ जुन चाहिँ अर्गन ट्रान्सप्लान्ट भएको पेशेन्टको बडीले त्योको इम्युन सिस्टम विक भएको हुन्छ र उले त्यो इम्युन सिस्टमले नाउ क्यान नट अपोज द अर्गन विच इज अ ट्रान्सप्लान्ट विच इज रिसिभ्ड फ्रम द अदर पिपल. Okay, so another one is statins. Now this is let's see, this is the Trichoderma polysporum fungus. Okay, from this Trichoderma polysporum fungus this cyclosporin A is obtained. So next one is the statins. Now it is also produced by the Monachus purpureus. Okay, it is a yeast. Now you can see this is a Monachus purpureus. Now this is a yeast, certain groundnut-like structure, right? This is a yeast. यो के रहेछ yeast हो. योबाट चाहिँ के बनाउँछ भन्दाखेरि चाहिँ now statins is produced from that Monachus purpureus and it is used as a blood cholesterol lowering agent. This blood cholesterol is a certain unwanted fat which will be there which will be accumulate in the blood vessels. हाम्रो blood vessels मा blood transport गर्नुपर्ने हुन्छ, circulate गर्नुपर्ने हुन्छ throughout the body. So because of a certain this cholesterol को excess cholesterol भएको कारणले गर्दा this is a certain group of aggregations of a certain unwanted fats यो आएर चाहिँ हाम्रो blood vessels मा बसिदिन्छ. So if that will be developed inside the blood vessels अरु livers हरुमा भयो organs हरुमा deposit हुन्छ तब that blood vessels मा blood को transportations मा problem हुन्छ. Now the vessels will become very narrow, so blood transportation मा problem, livers हरुमा अरु organs हरुको functioning बिगारेर जान्छ. So this is also a very it is a big problem. So cholesterol लाई चाहिँ बढाउनु हुँदैन बडीमा. So blood cholesterol is very dangerous. यसले चाहिँ के गराउने चान्सेस हुन्छ blood vessels लाई blockage गरेर breakage गराउने चान्सेस हुन्छ. Okay, now this statin, it is an enzyme which will be responsible for synthesis of cholesterol. Now cholesterol लाई के गरिदिन्छ inhibit the synthesis of cholesterol को production हुनु दिदैन बडीमा by utilizing this Monachus purpureus बाट बनिएको statin जुन चाहिँ enzyme लाई use गरेर. So this is all about the enzymes and their actions. Okay, so next one is the microbes in sewage treatment. Okay, so this sewage treatment को लागि चाहिँ के गर्नु पर्यो. So in previous times मा चाहिँ they have been utilizing certain chemicals. Okay, and all the wastage has been like throwing in the riverside areas, in the landsहरुमा जतै मैलाहरु फ्यालिने काम गरिन्थ्यो. त्यो कारणले गर्दाखेरि चाहिँ the organism which is present in the like watersहरुमा हुने. Okay, so त्यो त्यहाँको nearby site मा बस्ने जुन चाहिँ human beings are facing large amount of problems. Okay, त्यतिखेर चाहिँ के गर्यो. Now this sewage treatment मा चाहिँ after utilizing these microbes, now these microbes will be digesting all the waste material, all the decay material present in that waste. Then these microbes will be very, very helpful in eradicating the excreta, such as sewage, municipal waste water, that is the contains large amount of human excreta and organic matter and microbes. र जति पनि यो sewage छ. Okay, municipal waste water, that means the water which is coming out from the towns, cities. यिनीहरुमा चाहिँ के हुन्छ भन्दाखेरि चाहिँ large amount of human excreta हुन्छ, मैला हुन्छ, waste water हुन्छ, त्यसमा a large amount of organic matter पनि हुन्छ र microbes पनि present हुन्छ. Okay, this sewage is treated in a sewage treatment plants. अब यसलाई चाहिँ कहाँ लान्छ भन्दाखेरि चाहिँ sewage treatment plants ma lancha. So this is the aerial view of the sewage treatment plants. So your plants haruma tyo jun chai water which is coming out from the cities and the towns jasma chai ke cha human excreta, okay, manche bara niskeko maila, organic matters jati pani hamro household kura ma niskeko maila jati pani microorganisms haru cha त्यसलाई चाहिँ अब sewage treatment plant ma lancha to make it less polluting. यसलाई के गर्नु पर्यो, less pollute बनाउनुको लागि it includes stages, namely primary treatment and secondary treatment. र यहाँनिर लगिसकेपछि चाहिँ certain treatment हुन्छ, sewage treatment plants मा लान्छ. Now there will be the treatment that is of the primary treatment and the secondary treatment हुन्छ. Okay, so we will study one by one. Let's see in the primary treatment. This primary treatment, it is a physical treatment. यो primary treatment चाहिँ के हो, physical treatment हो, जहाँनिर चाहिँ it is the physical removal of large and small particle from the sewage. यसमा के गरिने काम गरिन्छ भन्दाखेरि चाहिँ first of all जति पनि the waste material which is present which is present in that sewage, then that will be removed physically. हातले टिपेर हुन्छ कि देखेर हुन्छ कि अथवा फिल्ट्रेट गरेर हुन्छ कि, ओके, त्यसलाई चाहिँ रिमुभ गरिन्छ large particle or small particle from the sewage. And it will includes removal of floating debris by sequential filtrations. माथि जति पनि फ्लोट गरिराखेको मैला डेब्रिसहरु छ त्यसलाई चाहिँ फिल्ट्रेसन गरेर मैला निकालिन्छ. अब अर्को चाहिँ removal of grit, that is soil and debris by sedimentations. अर्को चाहिँ first one is the filtration ले गर्यो, second was sedimentations of the debris and soil. So all solids that settles from the primary sludge and the supernatant from the primary effluent, जति पनि अब सलिड्सहरु छ जो चाहिँ सेटल भएको छ प्राइमरी स्लज देखि लिएर सेटल भएको सलिडहरुलाई र जति पनि सुपरनेटेन्ट फर्म अफ द प्राइमरी इफ्लुएन्ट माथि माथि तरिएको जति पनि मैलाहरु छ तिनीहरुले चाहिँ यो दुईटा कुराले प्राइमरी इफ्लुएन्ट बनाउँछ. अब त्यो प्राइमरी इफ्लुएन्ट यसमा के छैन, बलुवाहरु डेब्रिसहरु, यसमा लार्जर पार्टिकल्सहरु के छैन, ओन्ली द लिक्विड पार्टिकल्सहरु मात्रै छ. त्यसलाई चाहिँ हामीले के गर्छौं भने सेकेन्डरी ट्रिटमेन्टको लागि चाहिँ that effluent will be consisting of a primary sludge and supernatant, okay, from the primary effluent. So यसलाई चाहिँ हामीले कहाँ लगिन्छ भने we will take these to the secondary treatment. That means the primary sludge भनेको and this effluent means thick mud with a liquid portion. So माटो एकदमै thick mud हुन्छ त्यसमा र तर त्यो mud चाहिँ के हुन्छ, liquidy हुन्छ. Such type of solutions is known as effluent. Okay, you can see again this is the aerial view of the sewage plant where all the treatment will be conducted. Okay, so next one is the secondary treatment. So we know that secondary treatment ma ke aako cha, effluent pass bhako cha. Okay, now this effluent will be this secondary treatment is also known as biological treatment, and this effluent which is coming after the primary treatment will be like stored, will be passed in a large aeration tank and constantly aerated. That means यो aeration tank मा के छ, certain airs हरु छ र यहाँनिर चाहिँ constantly aerate अथवा चाहिँ एकदमै more shake गर्छ यहाँनिर चाहिँ, where it is constantly shaked, okay, and mechanically air is pumped into it. Okay, this allows a vigorous growth of aerobic microbes into flux. अब एकदमै यहाँ हल्लाको हल्लाको शेक गरेको छ कन्टिन्युअसली, त्यतिखेर चाहिँ एयर पनि पम्प गर्दैछ. सो यो टाइममा चाहिँ दैट एयर को प्रेजेन्स को कारणले गर्दाखेरि चाहिँ लार्ज अमाउन्ट अफ माइक्रो अर्गानिजम्स इन्टु फ्लक्स. दैट मिन्स द ग्रुप अफ द colonies of a microorganisms will start, that is the aerobic microbes, that is which will be grown in presence of the air, will be started growing in flux. The masses of bacteria associated with the fungal filaments to form mesh like structures. यहाँ के बनिन्छ भने अब जब एयरहरु बाहिरबाट आउँदैछ, certain bunch of a group of a bacteria will start developing, र यो bacteria सँगसँगै चाहिँ fungal filaments पनि हुन्छ, mesh like structures will be present, and while growing this consume the major part of the organic matter in the effluent. र जुन चाहिँ यो microorganism grows, जस्तो this fungal filament and this bacteria grow हुँदाखेरि चाहिँ this has to take nutritions. So those bacteria will take nutritions from this organic matter which is present in the effluent. That means these microbes consume the major part of the organic matter in the effluent. So that means this reduce the biological oxygen demand of the effluent. अब यहाँनिर चाहिँ के हुन्छ, biological oxygen demand चाहिँ के भयो, reduced भयो. That means this BOD or biological oxygen demand refers to the amount of the oxygen that would be consumed if all the organic matter in 1 liter of water was oxidized by bacteria. So के भयो, अब यहाँनिर चाहिँ oxygen को demand चाहिँ के भयो, घटेर गयो. Okay, so the sewage water is now treated till the BOD is a biological oxygen demand जति reduce हुँदै जान्छ त्यतिन्जेलसम्म चाहिँ यो sewage treatment चाहिँ treat गरिबस्छ, so that जब oxygen को demand घटेर जानु भन्नुको मतलब चाहिँ जति पनि waste materialहरु छ सबै oxidized भइसक्यो, सबै digest भइसक्यो भनेर. So BOD ले चाहिँ के measure गर्छ, now test the measures to take a rate of the uptake of oxygen by microorganism. Now this biological oxygen demand will helpful in the testing of the measures of कि कति सम्म चाहिँ microorganism ले चाहिँ oxygen लाई के गर्यो, take गर्दैछ. Okay, simple of water, and thus indirectly BOD is a measure of the organic matter present in the water. Okay, and the effluent is then passed into the settling tank. अब त्यति भइसकेपछि चाहिँ बायोलोजिकल अक्सिजन डिमान्ड भन्नुको मतलब जति अक्सिजनको डिमान्ड हुँदैछ त्यति नै माइक्रो अर्गानिजम प्रेजेन्ट छ भनेर बुझ्न सकिन्छ, र त्यति नै वेस्ट पनि प्रेजेन्ट रहेछ भनेर बुझ्न सकिन्छ. जति अक्सिजनको डिमान्ड घट्दै घट्दै जान्छ त्यति नै के भयो, माइक्रो अर्गानिजम कम्ती हुँदैछ, र जति पनि वेस्ट मटेरियलहरु अब डाइजेस्ट भइसक्यो र सकिँदै गयो भन्ने बुझ्न सकिन्छ. Okay, so after that this effluent is then passed into a settling tank. अब यसको बादमा चाहिँ जुन चाहिँ effluent छ यसलाई चाहिँ कहाँ पास गर्दिन्छ, settling tank मा पास गर्छ, where the bacterial folks are allowed to sediment. settling tank मा चाहिँ जति पनि bacteria को एउटा group of bacteria थियो त्यो चाहिँ के भएर जान्छ, एकदमै sediment भएर जान्छ. Okay, and this sediment is called activated sludge. यो sediment लाई चाहिँ के भनिन्छ हामीले, activated sludge भनिन्छ. Okay, so this is the biological sewage अथवा settlement plant. So first of all के गर्यो हामीले भन्दाखेरि चाहिँ so settlement भयो, त्यहाँबाट चाहिँ aeration, and then primary, त्यहाँबाट चाहिँ solid will be go out. This is the pictures of the biological treatment. So we will study now this small part of the activated sludge is pumped back into the aeration tank to serve as the inoculum. So this, so after this settlement भइसकेपछि चाहिँ दिस इफ्लुएन्ट सेटल भइसकेपछि चाहिँ हामीले एरिएसन ट्याङ्कमा यसलाई फेरि पठाउनु पर्ने हुन्छ बट स्मल अमाउन्ट अफ दिस फल्क अफ द माइक्रो अर्गानिजम विल अगेन गिभन ब्याक टु दिस लाइक aeration tank for the inoculum. Okay, now the remaining major part of the sludge is pumped into the large tank called aerobic and aerobic sludge digester. त्यसको बादमा चाहिँ के गर्छ भन्दाखेरि चाहिँ नाउ त्यसलाई चाहिँ एनएरोबिक स्लज डिजस्टरमा फेरि हामीले ट्रान्सप्लान्ट गरिदिन्छ and the remaining major part of the sludge is pumped into the large tank ma feri for the anaerobic sludge digester. So some of anaerobic bacteria चाहिँ के छ भने त्यहाँनिर digest the bacteria and fungi. So in the sludge by producing gas like methane, this is H2S, sulfur and carbon dioxide. And this methane बनिन्छ, sulfide and carbon dioxide will be produced and these gases form the biogas. That means once हामीले biological oxygen demands of a sewage or waste water लाई reduced भइसकेपछि चाहिँ त्यो effluent लाई हामीले कहाँ पास गरिन्छ भन्दाखेरि चाहिँ settling tank मा पास गरिन्छ and settling tank मा पास गरिसकेर चाहिँ where the bacterial flocks are allowed to sediment एकदमै settling tank मा sediment हुन्छ र जुन चाहिँ यो sediment लाई भनिन्छ activated sludge. इसलिए भन्छ activated sludge. Okay, and this activated, a small part of this activated sludge is pumped back into the aeration tank मा लगाइन्छ and to the serve as the inoculum. aeration tank मा लगाइसकेपछि चाहिँ inoculum, that means this sludge will be consisting of the bulk of bacteria. That inoculum भनिसकेपछि small part of the a part of the original one which will be given back to the aeration tank so that anaerobic sludge digester जो हुन्छ. that means जति पनि remaining part of the sludge छ त्यसलाई चाहिँ that will be pumped into the large tank called aerobic sludge digester. यहाँनिर चाहिँ जति पनि ब्याक्टेरियाजहरु छ यो चाहिँ anaerobically, that means oxygen को absent मा पनि माइक्रो अर्गानिजम ग्रो हुन्छ र यसले चाहिँ जति पनि ब्याक्टेरिया फन्जाइहरु प्रेजेन्ट थियो तिनीहरुलाई डाइजेस्ट गर्ने काम गर्छ अनि स्लज बनिन्छ. जब डाइजेसन भइसक्छ फर्स्ट मा एरोबिक ब्याक्टेरिया थियो, एरोबिक ब्याक्टेरियाले माइक्रो अर्गानिजमलाई जति पनि डिकेड पार्टलाई डाइजेस्ट गर्यो. त्यसको बादमा फेरि एनएरोबिक स्लज डिजास्टरमा चाहिँ एनएरोबिक ब्याक्टेरिया डेभलप हुन्छ. एनएरोबिक ब्याक्टेरियाले एरोबिक ब्याक्टेरियालाई डाइजेस्ट गर्छ. ओके, अनि त्यो डाइजेस्ट गरिसकेर ब्याक्टेरिया र फंगाई डाइजेस्ट हुन्छ त्यतिखेर चाहिँ के प्रोड्युस हुन्छ सर्टेन मिक्सचर अफ ग्यासेस दैट इज मिथेन, हाइड्रोजन, सल्फाइड, कार्बन डाइअक्साइड चाहिँ प्रोड्युस हुन्छ अनि यो ग्यासेसहरुलाई चाहिँ हामीले बायोग्यासमा बनाउन सकिन्छ. एन्ड दिस एनर्जी एज इट इज द इन्फ्लामेबल हुन्छ. ओके, now after this the effluent जति पनि remaining effluent छ जसलाई microorganism ले treated गरिसकेको the effluent from secondary treatment plant is released into the natural water bodies like rivers and streams. So river streams मा अनि मात्रै बाहिर लगाइदिन्छ. So previously चाहिँ if there were no primary and secondary treatment नहुँदा चाहिँ के हुँदै थियो भने एकैचोटी बाहिर लगेर फ्याक्ने काम हुँदै थियो. तर जब पनि यहाँनिर ट्रिटमेन्ट भइसके त्यो बाहिर लगेर फ्याक्दाखेरि चाहिँ सर्टेन त्यो माइक्रो अर्गानिजम्स सल्फाइड जति पनि मिथेन जति पनि कार्बन डाइअक्साइड डाइरेक्टली सी वाटरमा जाँदै थियो, रिभर वाटरमा जाँदै थियो एन्ड दिस वाज ह्याम्पेरिङ. यसले चाहिँ के गर्दै थियो, ह्याम्पेयर गर्दै थियो नि, डिस्टर्ब गर्दै थियो द इकोलोजिकल ब्यालेन्स अफ द एक्वेटिक एनिमल्स. सो अब आफ्टर दिस सेकेन्डरी ट्रिटमेन्ट जति पनि ब्यालेन्सहरु छ मेन्टेन हुन्छ, लेस पल्युटेड त्यो जुन चाहिँ सिवेज मटेरियल वेस्ट मटेरियललाई मात्रै चाहिँ के गर्दैछ, दिस विल बी लाइक रिलिज्ड इन्टु द नेचुरल वाटर बडिज. बुझ्यो? But because of like due to the increasing urbanization, okay, this sewage is being produced in much larger quantities than ever before. So however the large number of sewage treatment plants has not increased enough to reach quantities. अब यति साह्रो बेसी पनि sewage treatment plant चाहिँ के भएको छैन, बनिएको छैन. यो सब मैलाहरूलाई ट्रिट गर्नुको लागि चाहिँ त्यो कारणले गर्दाखेरि चाहिँ इन सर्टेन एरियाजमा चाहिँ दिस अनट्रिटेड सिवेज इज अफन डिस्चार्ज डाइरेक्टली रिभरमा डिस्चार्ज गर्छ सो द्याट दिस विल लिड देयर एयर पल्युसन्स एन्ड इन्क्रिज इन वाटर ब्रोन डिजिज एयर पल्युसन्स हुन्छ र डिजिज पनि वाटर ब्रोन डिजिजहरू हुने चान्सेस हुन्छ ओके एन्ड त्यो वाटर बोर्न डिजिज भएको कारणले गर्दाखेरि चाहिँ जुन चाहिँ Government of India, the Ministry of Environment and Forest has initiated Ganga Action Plan and Yamuna Action Plan to save the major rivers of our country and of a sewage treatment plant like utilized गरेर चाहिँ that only treated sewage only discharged in the rivers. Okay, यो कारणले गर्दाखेरि चाहिँ this Yamuna Action Plant र Ganga Action Plant को कारणले गर्दाखेरि चाहिँ यो sewage action plant चाहिँ developed भयो र directly sewage लाई चाहिँ हामीले वाटरमा डिस्चार्ज गर्नु पाउँदैन सो नेक्स्ट इज दिस बायोलोजिकल ऑक्सीजन डिमान्ड This biological oxygen demand that we have already studied in alikati isko just this biological oxygen demand represents the amount of dissolved oxygen required for the complete oxidation of the organic matter present in 1 liter of water by bacteria at 20 degree Celsius. That means जति पनि माइक्रो अर्गानिजम के भएको छ प्रेजेन्ट छ केमा वाटरमा डिजल्भड भएको छ वाटरमा त्यसलाई चाहिँ डाइजेस्ट गर्नुको लागि अक्सिडेसन गर्नुको कम्प्लिट अक्सिडेसन गर्नुको लागि चाहिँ 1 लिटर अफ वाटरमा कतिसम्म चाहिँ हामीलाई के चाहिन्छ अक्सिजन चाहिन्छ कति अक्सिजन रिक्वायर्ड हुन्छ कति डिग्री सेल्सियसमा 20 डिग्री सेल्सियसमा चाहिँ 1 लिटर अफ वाटरमा भएको माइक्रो अर्गानिजमलाई डाइजेस्ट गर्नुको अक्सिडेसन गर्नुको लागि चाहिँ कति अमाउन्ट अफ डिजल्भ अक्सिजन युटिलाइज्ड हुन्छ त्यसलाई चाहिँ भन्छ बायोलोजिकल अक्सिजन demand. Okay, this biological oxygen demand will measure the amount of organic matter present in water by measuring the rate of oxygen taken up by microbes. That means microbes ले जति oxygen लिन्छ okay जति oxygen चाहिँ microbes ले लिन्छ त्यति नै organic matter is present in the water भन्ने कुरा बुझिन्छ okay and this higher biological oxygen demand indicated that water is highly polluted जति BOD छ biological oxygen demand that means oxygen को demand जति बेसी छ त्यति नै water is highly polluted with a organic matter and a lower value of a BOD means the water is less polluted or normal okay